SAS class with Amanda. Hey. Hello, in this video we'll be describing distributions with numbers. The number we'll concentrate on today is the mean, also known as X bar. So you should know this symbol, memorize it, because we'll be using it for the rest of the class. Anytime I say the mean of a data set, you'll be seeing X bar with it. Alright, so let's just remember the example. Here we're at Comic-Con. There are two booths for Aquaman. One is selling comic books, and another is Jason Momoa and Amber Heard giving autographs. And so clearly this example is designed so that older people will go to the comic books, and then younger people will go get their autographs because they're more familiar with the movies, or maybe they only know about the movie. We have 6 observations. A log was kept of visitors and their ages. So here at booth 1, which is the one for comic books, we have ages 32 years old, 48 years old, 45, 38, 27, and 40. And then for booth 2, which is where the stars are giving autographs, 15 years old, 16 years old, 17 years old, 22, 26, 18. So a mix of Gen Z and millennials. So what we wanted to do was compare the booths and figure out which booth appealed to what age group and what type of distributions existed. So we created a stem plot. We figured out the 5-number summary. So I'll just rewrite the 5-number summary. Booth 1. So remember, when we write out the 5-number summary, we do min, Q1, median, Q3, and then max. And then we figured out what these values were. So the minimum for booth 1 is 27. The maximum for booth 1 is 48. And then the median was 39, and Q1 is 32, and Q3 is 45. Alright, so now that we have our 5-number summary again for booth 1, I'm going to make it a 6-number summary and actually add our mean, which is approximately 38.33. Okay? And then we're going to do the same thing with booth 2. And we'll talk about how we calculated these X bars in a second. Q1, median, Q3, max, and I'm just going to go ahead and write X bar here. So your minimum is 15, maximum is 26, Q1 is 16, median is 17.5, and Q3 is 22, and the X bar is approximately, or I guess exactly, 19. Also recall that we said that booth 1 demonstrated a left-skewed distribution, and booth 2 showed a right-skewed distribution. Okay. So let's first talk about how we calculated the mean. So its X bar is equal to, and if you haven't calculated the mean or average in the past, then use this as a way to figure it out. So there were 6 numbers in each data set. Let me just scroll back up, sorry. So we're going to label each of these observations x1, x2, x3, x4, x5, and x6. Okay, so in other words, x1 is equal to 32 for booth 1. x2 is equal to 48 for booth 1. Okay, so we have 6 observations. So X bar is equal to x1 plus x2. So all you're doing is adding up all those numbers. And dividing by n, or the total number of numbers in your data set. So here, n for booth 1 is equal to 6. I'm just going to use n sub 1 so we know it's for booth 1. And n sub 2 is also equal to 6. It just so happens that there are the same number of numbers in each data set, but that doesn't always have to be true. Okay, so we would plug in each of those those pieces of data. So, for example, for booth 1, this would be x1 is 32, x2 is 48, x3 is 45, x4 is 38, x5 is 27, x6 is 40. But if we were talking about booth 2, then this would be 15, 16, 17, 22, 26, 18. So I'll just do it for booth 2. Okay, so x bar would be 15 plus 16 plus 17 plus 22 plus 26 plus 18. And since there are 6 numbers here, we divide the whole thing by 6. And I'm only working this out so that you understand how we find the mean, but you do not have to do all of this in your head. You are allowed to use calculators or R. And so here, if we added all these numbers up in a calculator and divided by 6, we would get 19. I won't calculate the mean for booth 1. I'll let you do that and check my work. What we'll talk about is how for skewed distributions, x bar is pulled toward the tail because it's sensitive to outliers toward the tail. Okay, so take booth 1 for example. It's left skewed, and we know it's going to have this sort of shape, okay, where the extreme values are on the left and most of the data is on the right. Okay, so remember that the median is about 50% of the way to the left and to the right. Okay, so the median is going to be where a bulk of the data is, because 50% of this data is going to be here. Okay, so what we have is our median will be at this value, and the x bar, because it's sensitive to outliers, will be pulled towards the left. So if the distribution is left skewed, your x bar is actually going to be smaller in value than your median. Okay? And this is true for booth 1, because our x bar is approximately 38.33 and our median is 39. It's not much of a difference, but it is a difference such that we can say that it's left skewed. And same thing with something that is right skewed. Okay, so our median, again, will be where most of the data is. And then our x bar will be pulled towards the tail. Okay, and here this says that our median is smaller in value than our x bar. And we see that our median for booth 2 is 17.5 and x bar is 19. So here's another way you could figure out whether a distribution is skewed or not using the median and the mean. So we'll look at a new example where if you turn your head, okay, here's your head, here's your eyes, and your eye goes like this, here's your eyesight, okay. This distribution looks roughly symmetric, right, where our peak is happening at 7. So we want to describe the shape, so we can say roughly symmetric. Okay, there's one peak and clearly 2 tails. Okay, so we want to describe our center. Okay, so our median is 50% of the data to the left, 50% of the data to the right. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the middle is approximately 8, so 1, 2, 3, 4, 5, 6, 7, 8. So let's just make sure that there are 7 pieces of data on the side. 1, 2, 3, 4, 5, 6, 7. All right, good. So that tells us that our center is 71. And that's our median. Now remember, we want to calculate our mean. Okay, so what we would do is add 49 to 55 to 56 to 68 to another 68 to a 69, dot 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 to 92. So x bar is equal to 49 plus 55 plus 56 plus 68 plus another 68 plus all the way through 92. And we just established that 7 plus 7 is 14 plus 1 more is 15, so n is equal to 15 here. So I'll just write that here so we don't forget. Alright, and this is equal to 71 inches and 71.67 inches. Alright, good. Now, our data is roughly symmetric, and the first thing you should see now from our mean and median is that they're approximately the same. Okay, so x bar is approximately our median when our data is roughly symmetric. Okay, so the difference between 71 and 71.67 could be large or it could be small depending on your scale. But in our case, in terms of measuring height in inches, it's not that big of a difference, and so it clearly demonstrates that the data is roughly symmetric. So to summarize, what we covered is how to calculate the mean, how to determine the shape based on the mean, right? So if x bar is less than the median, that means x bar is pulled to the left, and this will be negative, and so our distribution would be left skewed, okay? And if this is positive, then the distribution is right skewed, and if this distance is only slightly negative or positive, but close to 0, that means that we have a roughly symmetric shape.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so narrow, 1/10. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.